Awesome. Welcome, everybody. Thank you for coming to our webinar. I'm Arjun. I'm a senior developer advocate at Pinecone, and this is my coworker, Jenna.
Hey there. I'm a staff developer advocate at Pinecone as well.
And we heard a lot of stuff about RAG in 2025 over the past couple months, since January 2025. And Jenna and I were talking, and we thought, hey, it might be good to have a webinar to kind of talk about what does RAG look like in 2025? What are people saying, and what should we be talking about and thinking about when we implement it? And that's what we're going to do today. This webinar is called Why RAG Remains Essential for Modern AI. So let's get started. A brief agenda. We're going to go over what retrieval augmented generation is. So if you aren't familiar with RAG, don't worry, we got you covered in the first 5 minutes. We're going to talk about some of the most common arguments people have in 2025 against using RAG, and we're going to address each of them. After that, we're going to do a walkthrough of a demo showing how to implement RAG with Pinecone and one of the benefits that you can gain from doing so in 2025 with GPT-5. And then we'll have a Q&A session as well at the end. Let me fix that. Is that better, chat? Can you hear me a little more? Great. Awesome. So before we begin, we got to go over what RAG is, right? So RAG stands for retrieval-augmented generation. This is when you might have an LLM where you're passing information to the LLM by retrieving it from a database, like a vector database or any other sort of data store, and then you're conditioning the generation of that LLM based on that retrieved data. It looks something like this in this diagram. You might have a user that asks a question. The question gets embedded into something called an embedding model. That question gets turned into something called a vector, which for all intents and purposes of this webinar is a fixed size list of numbers. Your database might have a whole set of these vectors represented by the documents that you're indexing there. So maybe you're asking a customer support question and you've indexed a bunch of customer support documents. You want to find the document that's most relevant to this question that's coming in. That's what your search will be able to do. That's the retrieval part. Then you'll pass those retrieved documents and the user's question back to the user, and you'll generate an output based on that question. This is the core workflow of a lot of AI applications up to 2025. And people love it for a lot of reasons that we'll get into, but this is the basic mechanism. You're retrieving a set of documents that you've pre-indexed, you're passing it to an LLM, and you're kind of generating. It's kind of like looking for a reference. You're looking for a reference, you're using that reference to respond to your queries. However, recently, there's been a newer concept of agentic RAG. There's a lot of ways to define agentic RAG. There's a lot of ways to define agentic architectures. We're going to go with one that kind of goes from the perspective of tool use. So instead of having the user interact directly with the LLM, querying directly with a database, we might have something called an agent, which is an LLM that has the ability to take a discrete set of actions. Those actions are represented by tools. So you might have an agent that can search for support tickets, or look up documents, or update the status of something that the user has requested. And instead of the user directly doing those things, the agent can accept a user command, figure out the correct course of action that needs to be taken, and then execute those sets of actions. And one of those actions might be interacting with a vector database. So you might have an agent that takes in a user query, figures out what is the user actually trying to look for, and then transforms that query into maybe a set of subqueries or a set of tool calls to a vector database, gathering all the information it needs, and returning it back to the user for appropriate response. A lot of people have been implementing agentic RAG in the past couple of years, and it's caused people to make some statements. We're seeing things that kind of imply to us that people don't want to do RAG anymore, that RAG is not something that, traditional RAG, is not something that people think is worth the effort for. I mean, we've seen some wild stuff. We've seen think pieces shutting down RAG in favor of using context windows and prompt caching. We've seen people claiming that agents will take over retrieval entirely, maybe even without vector stores. We've seen better and better models get released. with Claude 4.1 and GPT-5. And these models know more and more about the world, so maybe they don't need to use RAG anymore. And we've also seen people claim that, you know what, I'll just let my LLM think harder instead of thinking about how to do retrieval, instead of thinking about how I can generate the best response. So Jenna and I have seen these responses on one side kind of grow in the background as a vibe. And at the same time at Pinecone, we've seen a lot of diverse, successful applications of RAG, ranging from customer support bots to RFP generation to all sorts of interesting things. So we were sitting there and thinking, like, where is this dissonance coming from? What is the disconnect between the successful applications of RAG and how people are thinking about RAG being used there, and what some developers are kind of claiming in 2025? And that brings us to the meat of today's webinar. Let's debunk together some common arguments against RAG. We have a few arguments we're going to go over, we're going to present them, and then we're going to talk about them together. Argument number one, and let us know in the chat if you've heard this argument before, any of these. Model hallucination rates are going down, so why do I need RAG? This is the argument that models are being trained on more and more data around the world, so why should I spend the engineering and development time to index maybe that same data and then figure out the best way of retrieving it and passing it to my LLM? What's the point here? Jenna, what do you think?
So you are absolutely right. We are seeing that hallucination rates are going down, and that is a really good thing. But there's still some things that a model can't give us no matter what, and that's why we need to ground our generation with actual data, up-to-date data on from our own company, private data, that type of thing. So there's what's commonly referred to as a cutoff date in relation to models. This cutoff date is the date of the most recent data that was used for training. And so what this means is a model doesn't actually know about anything, current events, news, anything, any other data that was created after that date. And so if we want to include any current data in our generation, we need to ground it with data. And so as an example, I can't ask about last night's basketball score because that data didn't exist yet when that model was trained. Another challenge here is these general purpose models that most of us are familiar with, they're really not going to know anything about your company's private or proprietary information, like trade secrets, any data about how your users use your systems or their preferences, or maybe like some of your user manuals might be public, but they might be there might be some internal documentation that is more specialized that is just not available publicly for these models to be trained on. So if you're building a system to support servicing your own complex manufacturing equipment, and you're probably going to need to ground that in your data. So that might be schematics, that might be user manuals, that could be internal support docs, data that is highly specialized, it's not found in the public domain, and it's not available for training. So if we use RAG for to ground our generation, that also means that we can reference the source data. So in our results. And so that just means that we can show citations alongside any insight or piece of data and where that came from, so that the people using that generated content they can do a couple of things. They can verify that it's accurate. They can go and reference that source again later on, but they can also trust that generated output is actually grounded in real and accurate data. So that leads us to our second argument.
Exactly, which is, well, you know, sure. Maybe the model like doesn't know the things that I want it to know. I'll give you that one. But Anthropic just announced a 1 million token context window. There are LLMs that have massive context windows. So I think long context windows will solve all my problems. I'm just going to find the data that I need. I'm going to shove it into my LLM call, and then it has it, right? Like, why do I need to do retrieval at all?
Great question. Okay, so it is certainly appealing that you just shove all that information into the model and let the model do all the work, right? So I would like to do that too. However, there are still some challenges here. And this comes down to cost, latency, and quality. And quality, just to like step back to the last slide, it's you still don't have access to that up-to-date or proprietary information. So that's one piece of it. But back to cost, LLM providers, they charge per token or 1 million tokens, typically. And so this means that as your context grows, over time, say over the course of a conversation, so does your cost. So in general, inference becomes slower with massive context windows, and the model has to deal with all of that information during that inference time, and that computational complexity increases. So even with optimizations during inference time, you're still gonna potentially have noticeable latency in real-time applications. So again, it's gonna depend on what your situation is and what your needs are. Um, and you might be thinking prompt caching is gonna solve all my problems. Well, so it does help, and it might be right in some situations. This is so prompt caching is going to be storing frequently used context in memory. So think of prompts that people are asking time over time again, and it's going to reduce cost and latency for repeated queries. But the catch here is that it's only effective if your use case actually supports that and fits those specific patterns that caching will benefit. So it's going to work best when you have static content that's reused frequently. Um, so you're going to have to ask questions like, how often are these prompts going to hit the cache? How often is my data changing? Are these prompts common enough to benefit from using a prompt cache? So if your data is dynamic, your cache hit rate is probably going to go down, and you're going to have to go back to full inference costs and latency. So even so, let's just say that cost is no object. We've figured out prompt caching. Speed is not an issue. There's still the quality problem that I mentioned earlier. So we've got these cutoff dates. We have this lack of proprietary and private data. And there's also this thing called the lost in the middle problem. And this is where language models, they are they're very good at finding information, recalling information that's at the beginning of a context and at the end of a context, but they struggle to find the stuff that's right in the middle. That's why it's called lost in the middle. So there's research that shows that LLMs are actually performing better when they're given fewer, more relevant documents in context. So this means that the risk of hallucination increases with larger context windows. So just another point here for the quality of your output. So
And
yeah,
oh yeah, I was just gonna jump in and say that some of these techniques are not necessarily mutually exclusive with building a RAG chat application. So we got a question about like, what if I do want to use caching? How can that help me in my RAG application? Well, maybe you have a user query and they need some document. You find that document, and for the rest of the conversation, they're just asking for that document. In that situation, it makes a ton of sense to cache that document bit because you don't want to send that, you don't want to recompute on that cache every single time, right? But you still need a way to search over and find what's relevant and important before you just throw everything inside your cache. And the second thing I'd pose to the audience is, let's say you do stuff your context window like 80, 90, 95%. What happens after the first message from the user? What happens after the 10th message from the user? Or the fifth or sixth tool call? You're going to start hitting that context window, and you're going to have to start thinking about, well, what do I actually need and what do I don't? And by using RAG, you're pushing that off much, much further by just pulling in the relevant bits that you need in order to maintain what you're doing. And if you don't do that, you have to engineer your context, which is more engineering left. So are you really saving any time?
yeah. So This means that RAG is going to give you a lot more control over each stage of the pipeline. So you have control over the ingestion and how you chunk your data. You have control over the how much data you're retrieving from whether it's a vector database or some sort of tool, other database or tool. Um, and that lets you control cost and latency because you can actually define like what your chunks look like. You can define that top K, how much data is actually retrieved from your database. As Arjun just said, like strategic use of prompt caching, strategic use of some of these things that we're talking about in our arguments. It doesn't mean that we don't do them. It just means that we use them strategically alongside or as a complement to RAG. Um, we also have more control over the accuracy and relevancy, and we can do this through figuring out which data sources are going to be used, query rewriting, and even re-ranking. It also lets us introduce a human in the loop element or a human element to use human in the loop workflows, and this lets an actual human assess whether those retrieved documents are the right ones. It lets them assess whether the tool call should be the right tool that gets called at a specific time. Um, and it lets us kind of evaluate in real time whether that what we're generating is what we need from a quality, relevance, and even to see if biases have been introduced, letting us continuously improve that process along the way. So here's the deal. If you choose to bypass RAG and only rely on context windows, you are going to actually be trading control for convenience. And so you'll have limited ability to customize and optimize at each stage of that pipeline for your use case. So our third argument, maybe you're considering training your own custom model or fine-tuning a model with your own data. That gives us more control, right, Arjun?
Well, you know, so a lot of people bring up fine tuning as like a reason to not use RAG. And the theory goes that, okay, my model doesn't know about the information that I need to know about. So I'll find an open source model. I will gather all the proprietary data I need, fine tune that model on that data, and now it knows it, right? Like we'll just like force it to memorize as much as possible. Um, I've fine-tuned models before with techniques like QLoRa and for doing specific tasks and things like that. It's not easy. The main challenges are you have to figure out what data you need. You need to make sure that actually fine-tuning on that data will not corrupt the existing capabilities of that model, which can happen if you fine-tune too much. You need to, it can be expensive depending on the size of the model and how often you're fine-tuning and maintaining the performance of that model. And your data will probably change over time, which means you'll have to update what the model knows over time to kind of figure things out. That's not cheap and that's not easy. And that's a whole set of engineering concerns that you have to be willing to take on. Now, if you have the expertise to do that, then sure, you can do that. However, if you do choose to do that, and a lot of our developers or customers kind of think about this, is that you could say, hey, I work in a really specific domain. There's not a lot of information about what my company does online. So any LLM trained on the internet is not going to know anything about that. I'm going to fine tune a model. That's completely fine. But using retrieval augmented generation can be a great way to have a fallback in the case that your model does not accurately understand the information that you're using. So you could take a smaller model, like a 1 billion parameter model, 7 billion parameter model, something in that range, fine tune it on your data, and then still use retrieval augmented generation in order to ensure against future hallucination. So that's kind of the benefit of using fine tuning and retrieval augmented generation at the same time. Otherwise, you're kind of just like trading risk that you don't necessarily need to be doing.
Okay. So I am hearing that cost and performance are a theme here. And I also hear that reasoning models are getting better and better. So why can't my agent just rely on those reasoning models for deciding what to do? What are some of the challenges that come along with this?
So this is something that we hear pretty often as well. And this is kind of like the think harder argument, right? Like, okay, well, insert LLM company here has released a model that can think harder or do something like that. And why don't I just like let it do that in order to solve whatever problem I'm working on? This is an example of another technique that is complementary to RAG and not in contention with. And what we do know about agentic workflows and what we've seen with our customers and our developers is that even if they know how to figure out the data that the user needs or are able to kind of service what the user needs, you still need new, accurate, and relevant data. Let's suppose you have an agent that has access to a set of like 5 or 6 tools, and in an average user conversation, probably uses like 5, 10, 15 tools to accomplish some goal. If that agent is not grounded in the correct information related to your company, your organization, or your application, you're going to have a chance of hallucinating between every tool call. And that will compound with every subsequent tool call. But if you ground the agent in between or doing each tool call, you'll reduce the risk. And yes, maybe you'll have a hallucination like at some point, but it will be later because you're grounding that model in the data that you need. And of course, just because you're building an agentic workflow doesn't mean that your problems of internal, private, or curated data go away. You're still going to need a way to kind of pass information to this model. Finally, the thing about reasoning models is that they consume a lot of compute, which could be good because you might need them to think harder about some application that you're interested in. But you don't want them to overthink. You don't want them to use too many thinking tokens because they don't have the context necessary in order to solve the tasks you want to do. So if you use retrieval-augmented generation, you can fix the amount of information that your reasoning model needs based on the chunks that you're returning, 3 chunks, 5 chunks. Those are a fixed set of tokens. And you can ensure that the model has all the information it needs to draw some conclusion. And maybe that model will use less thinking tokens in order to get to some task that you need to do. And that's less cost for you. So you can still incorporate RAG into your agentic applications, into your reasoning models, because they'll need to have access to this information. But another argument we hear is, cool, like I get it. They need access to information. But the application I'm building doesn't have a lot of data. So why do I need a database in general for my agent? Why don't I just have it locally with the user or have it be in some other sort of storage that just isn't that organized? I can just throw it in every time I want the user to reference something. Or maybe you're building an application that has a lot of users, but each user has a really tiny amount of data. So it doesn't make sense to kind of think about it any further than that. What do you do in that situation? Or how do you think about that?
Yeah, that is a great question. And this really comes back to kind of the theme that we've been talking about, which is control over cost, performance, and quality. So RAG is actually going to give you control over the governance and security of this data, which is essential for running in production, especially at scale. So it's going to enable data isolation at the user level. So in the case of maybe agents that are working, that do work for a bunch of users, they often need to access data that it corresponds only to that human that is interacting with it, which means that that data is specific to that user and can't live in a shared language model, but it can live in a shared database where it is either physically separated or architecturally separated in order to kind of isolate data for users. So if we consider an email management agent that goes beyond filtering and categorizing email to maybe it schedules follow-ups, it drafts contextually relevant emails, and escalates emails from key customers. So the emails, calendar, contact information that's accessed by that agent, it can't be shared across all users of that agent for a number of reasons, privacy being a big one of them. It also can't be used for training or fine tuning, but instead it needs to be stored separately and added to the context through RAG when that specific user needs it. RAG also enables role-based access control. So if you consider an HR system that offers support to both managers and their employees, people at different levels of the company need access to different types of information. So managers might need to be able to access performance review data, salary information, but employees, they only need to be able to access general company policies. So this way, you can actually implement fine-grained authorization that ensures that users only have access to augment prompts with specific pieces of data that they are able to access. a side benefit to this is that you can revoke access, update policies, delete data for compliance without ever retraining your models. So RAG, it's not just about the retrieval aspect of this. It actually creates this bridge between your system, your AI system, and sensitive proprietary data, bringing in up-to-date information, private information, and it gives you control over that cost, performance, and quality at every step. So now I know there have been a couple questions about a demo. We are going to do a demo right now. I'm going to get that queued up and need to
While
share.
Jenna is getting ready, I'm going to kind of explain to you all what we're going to demonstrate today. We're going to implement a quick example of retrieval augmented generation in 2025 with LangChain and OpenAI. And the example we have is quite interesting. We're going to show you how to use Pinecone's release notes to eliminate hallucinations in a RAG kind of call. So as we just found out in the chat, GPT-5 came out like last week, but its training date cutoff is 2025, basically. Or 2024, excuse me, September 2024. So it doesn't know anything about Pinecone releases since then. And we're going to show you how to fix that as a way to show what happens when you kind of implement this type of workflow.
Okay, I'm going to try and share.
Cool, cool, cool.
And you should be able to see, oops, move this over here so I can see you all. Okay, so you should be able to see our, this is our doc site. Is that what you're looking at, Arjun?
Yeah.
Okay. The notebook that we're going to go through today is this one over here under the RAG section, RAG with LangChain and OpenAI. I already have it open up here. I've gone through some of this already, executed some of the cells just to save for some saving some time for us. But we're going to be looking at kind of a common implementation or common application of RAG, where we give an LLM access to some more recent data. In this case, we are just going to be asking questions about Pinecone release notes over the course of a couple of years. Specifically, we want to ask questions about the most recent release. Um, so in this notebook, we, like I said, I've gone through some of this before, so I won't be executing all the cells. But we're going to be using LangChain, which is a framework for building AI applications, and this will help us build that RAG pipeline. We're using OpenAI's text embedding 3 small model to create our vector embeddings. And then we'll be using GPT-5 for generation. So in here, one of these first sections is going to be loading our release notes from these URLs. Again, I've already run this. And once we actually have that available, we're going to pre-process this data. And what this allows us to do is really going to be, we're going to take the information from our release notes, which is actually formatted in Markdown, and then we're going to chunk it into, we're going to use this Markdown text splitter from LangChain and chunk that into different features. So we'll key them off of the release date and the feature, so that we can get at them later if we need to by specific ID. So we download here. We're adding some metadata in here as well. And then we're actually going through each URL, downloading the link, splitting the text using the Markdown format that I mentioned earlier with the feature release and date. And then we're adding some of this metadata in. So this metadata is going to help us later on in one of these next steps. Now, so we've got our data, we've got it loaded into memory, we've got it pre-processed, and one document looks like this. So we've got the title of the feature. We've got some information about the feature, and then we've got our metadata. And if we look at a second one, we've got another feature. This one happens to be in 2025, which again, this is what we're asking about. And now we're going to actually, we need to set up Pinecone so that we can load this data into a Pinecone vector store. So if you remember back to one of those very first slides, the traditional RAG approach, this is going to be that ingestion step. So we've done some, we've loaded the data in, we've done some chunking, and now we're going to set up our Pinecone index in order to embed and upsert those documents. So this here is setting up our API key. So when we run this, we will see this little widget down here. And if I hadn't already run it, you would see a little blue button here that says something like get started or sign in or whatever, authenticate. You'll click that button. You'll either create a new Pinecone account if you don't have one, or it'll let you authenticate. And then what it's going to do is set up your Pinecone API key in Colab so that you can run this notebook. So that's already done for us. I've also gone through and set up my OpenAI API key. This is just another function that does that for me. If I were running this, I would click this button here and then enter in my API key here. I've already done that, as I said. So now we're actually going to set up the index. We create our Pinecone client with the API key. We leave this source tag in here. This is just tracking for our purposes to see who's using these notebooks. And then we create our index. So we've given it a name, LangChain Pinecone rag. We're checking to see if it exists or not. In this case, I've already done this, loaded everything in. But if it didn't exist, we would create the index with the index name, a dimension of 1536, which this dimension has to match the vector embeddings that are used by OpenAI's text embedding 3 small model. We're using the metric of cosine because we're going to do a semantic search, similarity search. And we're going to create this in AWS US East 1. So we initialize our client. We've created it. We get our index from the index, or the Pinecone client based on that name, and then we just do a describe. This just gives us a little bit of stats about our index. In this case, I already have vectors loaded in here. My total vector count is 104 vectors. If you're doing this for the first time, that's going to say 0, just so that you kind of understand. I've already gone through this before. Next, we need to do the embeddings. We're gonna generate some IDs for each of these documents that we're going to upsert or embed and then upsert. So you can see our data here. We have our, this is just our metadata, excuse me. We've got a release, month, year, the actual source that it came from, and the chunk number. And we're going to use this metadata in order to create some IDs. So I'm going to just jump down here really quick, and then I'll run to the top of this cell. Here, this is just a function that allows us to massage that metadata into IDs for each document that we're going to upsert. This allows us to get all features from this, or all chunks for this feature, or all chunks for this release later on if we ever need to do that. In this case, we have a specific reason that we need to do that. That is because the LangChain APIs require us to provide that ID. So here up at the top, we're creating our OpenAI embeddings model object. We're giving it our OpenAI key. We're telling it which model to use. Next, we create the Pinecone vector store, which is a wrapper around our APIs. And we tell it which index and which embeddings object to use, which model we're going to be using. And then we call this vector store add documents. So what this is going to do is it's going to take our documents and embed them using that model that we selected earlier. And then it's going to upsert them with those IDs into our Pinecone index. So we can see here, these are just the IDs, the output of the IDs. And this one I'm going to run. This is where I left off. So this will take just a second to run, a couple seconds to run here. We've got our IDs again, as I mentioned. And then next, we want to bring this all together. So we've got everything in our vector database, but now we want to, we could just look, what am I thinking of here? We're gonna do a couple things first. We're gonna set up this init chat model with GPT-5. This is gonna be the model that we're sending our prompt to. So with RAG, we're sending an augmented prompt with our results. But we haven't actually done that yet. So that's gonna be here. We're gonna do this. This is our query. So as I said at the beginning here, we're asking about version 7.0 of the Pinecone Python SDK. And it just so happens that version 7 is a very recent release. So we do our similarity search. So this is, again, the vector store is that LangChain wrapper around Pinecone. We call similarity search with our query and a top K of 5. So we're going to get the top 5 most similar results, or closest results to this query. And when we do this, let me actually run this one quick. When we do this one, we have our retrieved documents here. So we can see our first document has a release 7.0.1 as of 2025, May. We've got doc 2, some 7.1 to 3 versions, also 2025. We've got some others in here. You can see that we also had some come back that are version 6, even though we asked for version 7. And that's because those are still similar to version 7. They are just a little bit further away in the vector space. So we can tweak our top K if we need to, if it's returning stuff that is less relevant. We could tweak that top K to exclude some of those less relevant results. Okay, so now we've retrieved our data. So we've done the ingestion step, we've done the retrieval step, and now we're actually going to do both. We're going to chat with GPT-5 with our original query. So that will be without using an augmented prompt. And then we're going to chat with GPT-5 with the augmented prompt. So in this case, I'm just going to run this one quick. This is the original query asking about 7.0. And I see we're coming up on time here, so I'm going to wrap this up. I think these last two will be our end, and then we'll have time for questions.
And if you remember, the training cutoff for GPT-5 was October 2024.
Thank you for reminding me of that. Yes, 2024. So our response here, without our retrieved result, without augmenting that prompt, is I'm not aware of a 7.0 release. As of my last update, which happens to be September 2024, I don't have this information. Here's how you can add more information. So now we can do this with our pipeline in place. We are crafting a prompt that gives it the model a little bit of instructions. We're saying, here's the query, that original query asking about 7.0 releases. And then here's some context, extra context. Those retrieved documents, we have formatted that top 5 into this doc's content, and we're passing that as part of the prompt to the model. So if I run this, I should have started running it before I talked. If I run this and when it prints out, it's going to come back and it's actually going to talk about 7.0 based on those retrieved documents. So here we have, here's what's new in the Pinecone Python SDK 7.0 series, version 7.0.0, 7.0.1, 7.0.2. So we've got more accurate information. We've augmented it with our grounded data from the Pinecone index, and then we put it into a natural language output. So that is, that's it. That's RAG, and that's a very simplified version of retrieval augmented generation. I think we've got about 15 minutes here for questions. Arjun, do you have any queued up?
Yeah, let me go ahead and share my screen so we can get back to the prior uh, little view. So just a moment here, and then we can go ahead and ask some questions.
And I think what you're pulling up is that final slide, which is
Exactly.
a link to the notebooks on our doc site. So we've got the notebook that we on the previous slide was the notebook that we just ran through, and then we've got this one here is the list of all of our notebooks across any sort of search and retrieval augmented generation. That's kind of what we have at the moment. So it's using different libraries, different models to show you how to do some of these things.
And the point that we really want to drive home at the end of this webinar is we're using the most recent up-to-date model that we can, which is GPT-5. And yet, in order for us to do this basic operation of like what is happening now, we have to pull in external information. And if you kind of scale that logic to whatever application that you're building or even application information that's not accessible to your company, you're gonna have to do this type of common workflow. Cool. All right, it's Q&A time. And if you just want to hang out and you want to work on some of the other notebooks, go ahead and scan this QR code. It'll send you to all of the example notebooks that we have ready on Colab for you to get started. But for now, Jenna and I are going to go through and answer some of your questions. Let's start here. So we've gotten a lot of questions about caching strategy. So Sridhar and Luca have both asked us about what is the recommended caching approach with a Pinecone RAG application, and like what's a good example of what this should look like. I'll go ahead and answer this one. So when you want to use caching is when you're going to refer to that piece of information multiple times in your LLM call or your context. The reason why caching is nice is because you are pre-computing a set of tokens that you're going to compute every single time, and you don't want to spend whatever the current price is for those tokens again and again and again. So let's say you're building a customer support chatbot, which is a common thing that people do with Pinecone. You might have some user ask a question. You then pull in the relevant documents to answer that question, and you might want to cache those for the remainder of the conversation because you know that conversation will be about that question. And maybe if they ask something different about a different issue, maybe that is your signal to kind of eject those documents from your cache and pull out more information there. So if you know you're going to hit that information repeatedly, you need to use a cache to kind of look at those chunks in those documents. That's what I would suggest. And also, there are certain things that you'll probably do every single time. For example, if you're building an agent that does agentic RAG using Pinecone, you'll probably have a system prompt that explains to the agent what's in the database, how should you structure queries, what types of questions are you able to answer. That system prompt you can probably cache. And that way you don't have to pass that system prompt again every single time when you're interacting with the agent. It's pre-computed. Let's look at another question. Faisal is asking, do you recommend making chat conversations to be turned into vectors and fetched via RAG? Since you mentioned things like context might cost more over time. There are many different ways to think about this. Jenna, what do you think about this?
Sorry, I was answering a different question.
No, that's cool.
What was the
So
question?
the question is about like if you're building a chat-based application,
Yeah.
does it make sense to index that information in a vector database and retrieve it when you're thinking about how context will cost more over time. And I mentioned that there's a few different ways to kind of approach this problem.
Yeah. So uh I think it I'm not I think there's again a few different ways. I think you could vectorize it, but I think if you're ultimately trying to augment your chat conversation with data, that might not be the data that you want to vectorize. Your
Right.
conversation might not be the data that you want to vectorize. Um, Instead, it's going to be that kind of grounded data that you want to ground your chat in or your conversation in. Um, if for some reason, um, and this is an area I'm not terribly familiar with, but this might be where some like memory does come into play, where you want to have that conversation over time, but you still want to be able to reference it later. So you do save it off, but I'm not sure that that is necessarily when you'd want to vectorize it.
Right. And you know, like if your user's conversation, if the average links are like so short that they do make sense to include in your context, then it could make sense for you not to need to vectorize it and search over it, right? Because if you do that, you might be pulling things out of context and it might get kind of messy. But if you have long conversations that at some point you're like, oh, wait, I actually do need to find this thing that we talked about like last week or last session or something of that sort, then it might make sense to kind of implement this sort of RAG workflow for those conversations. But very often, you'll probably instead want to use RAG to retrieve that information that you need, like Jenna said. We definitely want you to use RAG, but we don't want you to over-engineer. So you should start with what you think works and then kind of go from there. Awesome. Go ahead
Yes,
and
I
mark that
very much
question.
agree with not over engineering. Yeah, I think
Uh,
I just want to add like one of the things as we were putting this content together that I've been thinking about is like we're talking about well the arguments are like why you shouldn't use RAG um or you don't need it. And we're Arjun and I are talking about why we actually think you do need it and why it is very useful and beneficial to many different scenarios here. But I think it's also really important to acknowledge that sometimes you don't need a technology and you can intentionally make the decision to not use it. So if your use case means that you don't need up-to-date information or you don't need to access private information, it might mean that you don't need this, and that's okay.
but we are making the point that most people end up getting to that
Yeah.
point, like graduating to having to index this
Yes.
information and searching it over time. I'm seeing a question in the chat. It looks like Sean is asking about using RAG with multi-model integration. So if we're using multiple different embedding models, we want to ground them in different aspects and then integrate. Yeah, this is common, and this is sometimes where people inject agentic RAG. So you might have multiple different sources, and you might need your agent to figure out which source you need to use in order to retrieve information from. So like you might have an image index, you might have an audio index or a document index, you want to search over those. And that's completely fine. That's still RAG. It's just that you're using them in different indices and kind of interacting with them in different ways. There's no different engineering that you kind of have to do other than routing your queries to the appropriate indexes when needed. And if you're using an agent, then you need to inform that agent and be like, hey, you know, this index is for when users are asking about this type of idea, or this index is for this other type of situation. You can totally ground information that way. It gets tricky the more sources of information you add because you have to think about how to rank the importance of that retrieved information. So if you have two indexes and you're retrieving the same amount of information from both, now you have double the information. So you have to figure out of all of that, what is important and what isn't. So that's what I would say kind of about that. Let's see, we have a few minutes left. If you have any more questions, please throw them into the Q&A so we can see them. Wait a second, I saw something. Oh, Ben is asking about prompt injection. I'll answer this one really quickly. This is a common attack pattern for like most AI applications. The way people tend to solve it is to use something like guardrails to prevent your agent from answering questions that it shouldn't really be answering. Or you can use a classification model on the incoming queries and be like, okay, these queries are out of bounds, we don't respond on these, and these queries are in bounds and we do respond on these. That's kind of tangent to whether you're using RAG or not. That's like any API you're exposing, you want to kind of sanitize the input that's coming in. So you want to do something about that there. Sanda's asking, where can I find some very clear tutorials? Well, if you go to this tiny URL, tinyurl.com/pinecone-notebooks, We have tutorials there for semantic search, RAG, agentic RAG, managing context, all of that amazing stuff. You can reference there, and we'll be able to kind of route things to you.
I want to
Um,
interrupt really quick and ask the chat one question. Um, I would like to understand what programming languages you would prefer your examples be in. And all you have to do is just drop the language in the chat, and we'll see it and we'll look at it later. But we're just kind of curious, like, are Python examples what people are looking for? Or other languages, JavaScript, TypeScript, Java. Um, Excellent. Thank you. Very helpful.
and when you say
I want,
Python, it would be great to hear if you want notebooks or if you want scripts.
yeah, yeah, exactly. Or full-fledged sample app type things. Um, any like just to like I just want to say another thing here. This feedback is super helpful for us to continue creating really good content for you and making sure that you have the right level of examples, the right type of examples in the right programming language so that you can be successful. There's one question that I think we could both maybe answer a little bit, which is how MCP will impact RAG. Um, I think it's going to make certain things a little bit easier. It is going to give like if we looked back at that original agentic reg diagram, it's going to make interacting with those tools easier, pulling information from various locations, whether that's a vector database, whether that is Slack, whether that is other tools that have that serve data through an MCP interface. I think it's going to just enable that a little bit more and make it easy for other people to kind of do more plug and play, even if you're not a developer.
Exactly. MCP is a way to standardize all these different tools that you kind of want to pass to your LLM, so you don't have to like re-implement each tool every single time. And it will be helpful for people that are like trying to wire a bunch of different, in my opinion, it'll be helpful for people who are trying to wire a bunch of different data sources into the same agent, like really easily, especially if all of those data sources have MCP access already. For example, there's a Pinecone MCP developer MCP. And in a few weeks, we're going to do a webinar on how to use the Pinecone MCP uh, and interact with it, upload data to it in a mostly no-code fashion. So if you use Claude Code, if you use Cursor, and you're interested to doing that, I will be going over live how to do that with the Pinecone MCP. So we'll show you what that looks like.
And I'm dropping the link to register in chat right now.
Um,
And I think this will come out if you're not um subscribe to our newsletter, the Pinecone newsletter, I would sign up for that because that will also give you access to these webinars on a regular basis as well.
Jax, that's going to help you figure out how to use RAG and MCP. That webinar will help a little bit. We do have agentic RAG applications, so you can also look at those as well. Cool. Let's see. Any final questions we want to answer in the last 2 minutes? We hope you really enjoyed this webinar, everybody. We really wanted to kind of create some content on what RAG looks like in 2025, especially in the advent of a lot of these newer technologies that kind of help or can work in tandem with them. There will be a recording. We'll probably upload it into YouTube. We'll definitely send it out via email. And yeah, any last words for our audience, Jenna?
No, this has been a lot of fun. Thank you for co-hosting with me, and thank you, chat, for having like a really lots of really good questions and making it very lively.
Yeah,
It's good to see what people are working on and like get feedback into like what we're building and why we're doing it. So thank you.
exactly. And if you have more questions, you can
Yeah.
find us online. You can find me on LinkedIn. Feel free to send me a DM, and
Yep.
we'll be happy to kind of point you in the right direction.
Yes. Thank you.
All right. Thanks, everyone.